Hey, what's up everyone? Welcome to this new video with a guest. Today my guest is Itay. Welcome Itay.
Thank you. Thank you, Vincent. How are you?
I'm doing good, and so I hope you're also doing great. I know that you've planned to tell us about a pretty interesting topic, which is you're going to share with us a few tricks to basically optimize your iOS app.
Yeah, I have some couple of tricks we found when developing apps and exploring other apps we have seen on the market, and we collect some of them and wanted to share with all of you guys.
So I think it's going to be really exciting. And before we get started, so Ite, you work at Emerge Tools, who sponsored that video. Maybe you want to tell us a bit what Emerge Tool does?
Sure. At Emerge Tools, our mission is to empower developers and make mobile apps development a breeze. We understand that challenges come with building mobile apps, from performance optimization, managing app size, or handling multiple screen size. That's why we develop a suite of powerful tools to assist you at every step of your way. We believe that everyone, regardless of their expertise, should have access to powerful resources that help them build exceptional mobile apps. Now that you know a little bit about MS Tools and what we do, let's dive into the main focus of the video. We have 8 tips and tricks that we want to share with you that will help you improve your apps and tackle common issues.
Okay, so before we get started, just wanted to say that if you want to learn more about Emerge Tool, you have a link in the description to check out their website and see the tools that they offer. Okay, so I guess let's get started and let's see what is the first trick that you have prepared for us.
The first tip we have is stripping binary symbols. It used to be an automatic process when we had a bitcode enabled for apps, but since Xcode 14 removed the support for bitcode, these symbols are often left behind and leading to larger app size. So, but don't worry, it's very easy to remove them. And even if you don't use Xcode, there's a very easy script that you can use. Let's first deal with what are these binary symbols I am talking about. These are symbols that include a lot of debug data for mainly for symbolification of the crash reports, but they are not really needed on the release builds. And since we can use the sims that are generated by Xcode, we don't actually need them on the final app, and they can take a lot of space on the final app that we have. To apply the first step to your app, the first option is enable all strip flags in Xcode. This includes stripping swift symbols, and if you are linking against a pre-built framework, you should also enable deployment post-processing that will apply the strip to all the binaries that are before completing your build. As I said before, if there's another way to doing this, if you are not using Xcode as a build mechanism, you can use this script that we will share after the video that allows you to completely strip the symbols from each one of the binaries that are in your app. Something I do want to mention is that this optimization step is not only applicable to your app binary, but also all third-party binaries SDKs that you may be using in your app. Many times, these SDKs contain these symbols for your symbolification process to have a lot more information in your crash reports, but you don't actually need them because you will have the DSIMs created by Xcode that will allow you to generate fully symbolicated crash reports. And let's see some examples we have on for some apps. We have, for example, the popular Spark app, where we can see that their strip symbols takes a lot of space. They are using almost 25% of their app just in their symbols, which they could easily remove with a single script. The same happens with the Southwest app that takes almost 20%. And we can also see that United also has the same problem, but in this case, it's not as bad, but it's still 8 megabytes. If you take into account that 8 megabytes download by thousands of people, that ends up being a lot of space lost to this process.
Yeah, these numbers are pretty impressive. So, like, basically, if you have any kind of marketing SDK in your app, for instance, you can assume that you might be able to gain a lot of app size just by running these scripts or enabling the setting in Xcode.
Exactly. Another tip developers can use to improve their app is sharing code and assets between different targets, especially those that are going to be bundled inside of the app, for example, extensions. When it comes to sharing resources, the recommendation is always to use dynamic frameworks. Why you would say that there are many reasons. First, if code and assets are added to both the app and the app extension directly, they will be duplicated in the app, so they will take and increase the app size. And secondly, using dynamic frameworks and ensure that we can actually share the same code and an asset in a single place in the app, and then we can use a mechanism called runtime search path that allows us to load this framework from a single and common place from all these extensions. This runtime search path it allows it's a method we have with the linker that allows us to specify where this framework will be located when the code is running. By using dynamic frameworks, you can avoid unnecessary duplication of the code and assets within the app bundle. And this optimization technique not only reduces the overall size of your app, but also improves the efficiency of resource utilization. How does it work? How can we do this? It's very easy. We can just have to create a dynamic framework in your project, move all the common code, logic, or assets that will be required in both app extensions or the app, and then we can add it to all of the targets. But first, we can see an example of one popular application that is not actually sharing assets between their apps. In this case, it's Pocket, which is a very popular app. And we can see they have three huge red squares in their app, where we can see they almost 25% of their app is used by the same bundle called Pocket Kit Textile Bundle, which they could remove and use in a single have it in a single place to avoid having almost 25% of their app. As I said before, or suggested way for doing this is adding a new framework target to your Xcode project. Then you have to make sure the method type is dynamic. It's usually the default one, but if you are already using one of the frameworks you have in your project, it's always good to make sure it's dynamic. Then, of course, move all the shared code and assets to this target, and then add this target to all of your apps, your extensions you are going to need. It's always good to also make sure the runtime search path is loading from the main app. In the case of extensions, it's going to be executable part double dot slash frameworks, which is going to be the main app frameworks path. Moving on with the third tip is optimizing assets. It's a huge challenge with on big apps, especially with a lot of developers, with handling all the app size that comes from assets, because apps start to grow in complexity and also with the file size for all the assets. Usually, this problem comes from images, videos, or audio files that they may have. One thing that we want to mention in this case is that on iOS, even if you are using vector files like PDF or SVG and Xcode, on the build process, Xcode will convert them to PNG files. So this means that the final size of your app is not really related to the size of these vector files. So you have to accurately assess the impact of these assets on your app. You have to manually build your app and check the final size from the vector to the PNG files. There is one way to doing this. This command line tool called asset util, which can give a path to your asset.car file that will allow us to see a lot of information. It happens a lot. Usually, companies will still use the vector file because it's much easier to use vector files with a single a file to modify. For example, in the case of Firefox app, they have a lot of vector files, which make it much easier for the designers and the developer to maintain. But if we take a look at their final app, we see that there are a lot of PNG created from these vector files, and that are usually much bigger than the original vector files. Our recommendation in this case is if you want to reduce this size, is to manually compress all the PNG files. For doing this, there are a couple options you can do. The first one, which is a local and open source tool called Squash. It's from Google Chrome Lab, so it's very trustworthy. You can run it on your machine, so this is not going to upload anywhere. And if you want to use it as a service with an API for your build process, you can also use services like TinyPNG, which allow you to do this automatically. In this scenario, I need to talk about images because they are usually the biggest asset used on your app. But this recommendation also applies to all type of assets. For example, audios, where you can use a MP3 or a wave file, or the same for a video. For example, there are a lot of formats. There are a lot of consideration you might want to take into account when which one is the one you need.
Yeah, I think I can really relate to this tip because no matter how much effort you make, it's so easy to add to your project an image that is like unnecessarily large. Like you export a banner from Figma and it exports it as a PNG, even though a JPEG would have done the job perfectly. But now maybe you have like a 10 megabyte PNG file in your project, and if you don't realize it, add a few more, and your project has gained 50 megs, just like that.
Exactly. There are a lot of formats for images. We have JPEG, we have PNG, we have the new format Hake. That it will really depend of your use that which one is the best suite for this case. And there are a lot of different solutions for this. For example, background assets might be replaced for code, and that will be much lighter, but will require CPU time. So you will have to try it and see which one is the best for you. Mainly related to this, we are going to talk about our fourth tip, which is the keeping the main thread light. Because usually when users notice a problem in your app, it's because it's laggy or having performance issues, and that's because we are doing heavy stuff on the main thread. There are a lot of things that may happen, like reading files, decoding JSON, decoding images. So performing that on the method will do a negative impact on the user experience, causing unresponsiveness and sluggish UI for the user. So in this case, it's essential to offload these heavy tasks to the background threads because all of these tasks are computationally intensive operation can consume significant resources and time, and by executing them on the main thread, other important tasks, for example, UI updates or user interactions that only run on the main thread will be delayed or blocked, leading to a poor user experience. In this case, I already talked about the decoding JSONs or reading files from the disk. The solution usually is very straightforward. We can always use Grand Central Dispatch for this to offload the task, or we can use actors, which make it much more nicer and look better on the new Swift projects. But on the other hand, we also have decoding images, which is a little bit trickier because usually we don't expect the decoding of images to take a lot of resources, but it may take a lot of time when you have a table with a lot of images. So luckily for us, Apple added a new API on iOS 15 for us, which is prepared for display, which will do the loading of the images on a background thread and will return us with the fully loaded image when it's ready. So you can make a better experience in the scenario that we are using iOS 15 or later. I will always recommend users to do a lot of testing with instruments or tool ET-Trace, which will let you see if you're having some problems on the main thread and some stacks are taking too long. So because we always want to make the user have the best experience, have the smoothest interactions with our UI.
Yeah, and you mentioned that this API was introduced with iOS 15, and I was trying to like think if this is not the version of iOS that also introduced the 120 hertz, the promotion screen, because I'm thinking maybe with that kind of very smooth scrolling, you need to be able to offload loading large images outside of the CPU. So outside of the main thread. That's why maybe like they introduced it late in the existence of iOS.
Exactly. Yeah, because with 120 hertz, you have like 8 milliseconds time
Yeah,
to prepare your frame. So yeah, probably that's
yeah,
the reason they.
exactly. And I can tell you, I've experienced it that it's very easy to mess up your scroll. And even if it's just a few frames, the user will notice because the human eye is very good at noticing this kind of broken pattern. And it's very frustrating.
Yeah, exactly. And it happens a lot if you take, I always just suggest you having like the oldest device you support to test there because, okay, it works fine on my iPhone 14 Pro Max that is brand new. But if you take an iPhone SE, which is the latest you are supporting, it can be really laggy
Yeah.
there. It happens a lot. It's always good to have like a policy to only test on the bad, on the not bad, on the least performant device you are supporting.
Yeah, that makes a lot of sense.
Going on with the fifth tip is to prefer static dispatch over other mechanisms of dispatching. The static dispatch is the mechanism that Swift determines at compile time which implementation of a function or a method we are going to use. In most scenarios, this this static dispatch will perform better and will be more efficient in your code. There are many scenarios where Swift will prefer using the static dispatch. The first of them is when we are dealing with value type, for example, with a struct or with enum, because we are not going to have another different implementation of this. So that in these scenarios, Swift will always try to use the static dispatch. But when we are working with some classes or protocols, this might not be the case. This is why we can use the final keyword to explicitly prevent any subclass or method override of our functions by marking the class with final or a method. We will allow the Swift compiler to safely know which implementation we are going to use. So it can safely decide which dispatch is going to use and which implementation is going to be used. In this example I have, we have the class and the animal class, which is might not use the static dispatch because if we call it, it might be a different implementation. But if we have a variable that is a dog, for example, since it is a final class and it's not going to have an override, it will prefer using the, the static dispatch. The second option for preferring the static dispatch we have is using the private keyword because we are going to to restrict the visibility of the method into the current scope. And with this, the compiler will have more information on about which implementation it might be available to use. So we'll prefer using the one it knows that's going to be the ones that is private. And the third option we have is enabling whole module optimization, because when you enable whole module optimization, the compilers build a single module instead of many separate modules. This allows the compiler to perform additional optimizations, including automatically applying the final attribute to all the methods without overrides for classes that have only internal access. But it's important to note that whole module optimization only applies to classes with internal access and won't affect public classes that may be subclassed by other modules. However, when applicable, it can provide significant performance benefits by leveraging static dispatch for methods that do not have overrides within the module. It's also worth mentioning that anything that is compatible with Objective-C, with add Object-C or add Object-C members, it's not going to use the static dispatch. It's going to probably use method dispatch, which is the one of the dynamic dispatch methods that iOS have. Enabling the whole module optimization is very easy. You just have to go to the settings of your project and add dash whole module optimization with dashes in between the words, and it will allow you to optimize the module.
And this one is pretty cool because when you change just one method from dynamic dispatch to static dispatch, most of the time you will get only a very small difference in performance unless your call is happening inside a very tight loop. But when you apply it at the entire module level, there are so many calls that can be optimized that in the end, when you add all of the little optimization, it can make an interesting difference.
Exactly. That's the benefit we have by using smart compilers that can lead that to a lot of optimization to our code. But it's always good to if you can manually do the improvements, because you will have more control about what's going on. In addition to choosing between static and dynamic frameworks or static or dynamic dispatch, there is another aspect of the iOS development that we have to take into account. That is selecting the right package manager you are going to use on your project. I'm going to talk about the most popular ones, which are the Swift Package Manager and CocoaPods. That it's very good to understand how they are built and which benefit and cons they might have. For example, talking about the Swift Package Manager, it offers several advantages, but it's also important to be aware of these drawbacks. The first thing that I want to mention is that SPM has limited support for mixed language projects. For example, if you want to make up something for a platform beyond Apple ecosystem, this is something we experienced when we were working with Itay, when we were adding support with SPM. We had a problem adding Objective-C and Swift on the same project. Another problem is that while the number of available packages is still growing, there are a lot of legacy projects that are not compatible with with SPM, or not compatible directly from them. You have to use a fork, which might not be as well maintained as the original the source. But they do. SPM has a lot of benefits. One of it's support by Apple, so we can trust it's going to be working for a long time without breaking all your dependencies that you have to change your Ruby version on your new CI. And it's very good that it integrates seamlessly with Xcode, where you don't really need to add some scripts or some stuff to make it work for your project. It just works, which is usually very good. And on the other hand, we have CocoaPods, which is one of the major drawbacks it has is that it integrates with Xcode, but it has to modify a lot of project files, which may lead to conflicts or issues when you are installing a lot of different dependencies from CocoaPods with different versions. But despite these drawbacks, CocoaPods has a rich ecosystem that has a lot of available pods for us to use. It has a big community that are very knowledgeable, and they are very community driven pod updates. And CocoaPods handles the process of integrating dependencies automatically, making it very convenient for managing third-party libraries. On the another benefit it has, it's support for plugins, which allows us to extend CocoaPods functionality to suit your needs. For example, there are plugins for precompiling your dependency for faster build progress, like Rugby, or there are a lot other options like making allow list of dependencies for your organization to only install some packages. And similar to Swift, we also have the capability of generating documentation automatically with some plugins. When choosing a package manager, it's crucial to consider factors such as your project requirements, your team familiarity with each one of them, which dependencies you might need, and where are they available, and which level of control do you really want to have on these dependencies or not. After weighting these factors, you can make a better decision which one is the best for your project. Also, one thing I want to mention is these are not the only two options you have for package manager. There are a lot of other options like Carthage or Bug, but they are not the most popular ones, but they also have benefits, and you might also want to explore them if you want, if you need for your project. Now let's delve into optimizing CoreML models. Many times these models are training with full precision, which is 32 bits. However, such precision might not always be necessary. In fact, reducing the precision can lead to faster model executions and smaller model size. Apple does provide various tools such as CoreML tools that can help us optimize this process. One approach to optimization is to reduce the precision of the model by half. If we are using half precision, which is 16 bits, you can significantly reduce the model size, but it doesn't affect that much the accuracy of the model, which might be very good for most apps. However, it's important to note that the choice of the precision should depend of the specific use case of the model and the model performance requirements. In some cases, further precision reduction might be suitable. For example, we can always quantize the models to 8, 4, 2, or even 1 bits, depending on the trade-off between the size and performance we are looking for. Okay, but what is quantization? Quantization involves mapping the model's weight to a reduced set of values, which can result into further reduction in the model size and faster inference times. Apple CoreML tools has an easy-to-use feature for quantizing models, making the process straightforward and very accessible. By optimizing CoreML models through precision adjustments and quantization, we can unlock benefits for faster execution, reduce memory footprint, and improve overall performance. In this case, my suggested approach is to test different quantization options to find the right balance between the model size and the performance. As I said, in the latest tools, CoreML 7, I think, which is still in beta, might be available soon with the new version of iOS. There are a lot of new optimization options that will be available for iOS 17 and later, which might be very good to test. One example of an app that is using a huge model is Remove Object. It's one of this number 14 on the graphic design category of App Store, which about more than half of the size of the app is actually a single model. It's about 176 megabytes out of 300. It's a lot. And this model is just for identifying objects in the image. It's a popular one, it's a Utonet for this. And if we take a look at the model, it is using half precision, which means that they could still be improving the quantization of this model if they wanted to reduce the app size. But used in the app in this scenario, identifying object is one of the main part on the core parts of the app, so they don't really want to reduce the precision. But for example, if our app is using a model for reading credit cards or some some user behavior, it will probably worth it to reduce the precision to improve the performance. And the latest tip on I have to share is one of the fundamental principles for app development, which is never stop improving. It doesn't apply only to our app functionality, but also to the code base and to ourselves. Swift, the programming language that we use, is constantly evolving, adding new features with every release. Because the Swift language team strives to make Swift core more expressive, readable, and maintainable by staying up to date with the latest Swift versions. You can take advantage of the new features and enhancements to write more efficient and elegant code. And the great thing about Swift updates is that they usually don't require you to change minimum deployment target of your app. This means that you can benefit of the new tools and features without changing the minimum support iOS version. You just have to upgrade your Xcode version to support the latest Swift release, and you can leverage modern language constructs, improve syntax, and optimize performance. It also opens a door to utilizing new frameworks and libraries that are built on the latest Swift UI, Swift capabilities. For example, in the latest Swift version, is 5.9, we have macros that allow us to dynamically manipulate our project Swift code base before it is compiled, allowing us to inject extra functionality at a compile time. We also have if and switch expressions that allows us to assign in a single line a new different values. We also have the non-copyable structs and nums, and also the consume operator that allows us to end the lifetime of a variable binding, which are all great tools that we can use to improve our code base and create new features of your app.
Yeah, it's a very exciting time for Swift. Personally, I think I'm very curious to see how the macros are going to evolve because they're extremely powerful. It's basically you are actually writing a compiler plugin. You can do a lot of things. You can do a lot of things bad with macros. So I'm really curious to see how the community will the usage the community will find for macros over the coming year. Really curious about that.
Yeah, they are very powerful. The same, almost as powerful that they are in C, but they have the type safety that Swift has. So it means that they have some different use cases that might be very useful. I'm still very looking forward to using them on production apps.
All right. Thanks a lot, Itay, for going over these tips with us. I've definitely learned a couple of things while we recorded this video. So I can only hope, but I'm pretty sure that people watching the video have also learned a few things. So thank you for sharing these tips with us.
Thank you for having me, and feel free to check out our website, emergetool.com, and our blog. We are constantly publishing new things we find out on apps or new tricks we find, and they are very cool to read. So feel free to read them.
All right. I think I just have to say thanks again, Itay, for joining me. Thanks again, Emerge Tool, for sponsoring this video. If you want to learn more about Emerge Tool, you have all the links you need in the description. And to finish, thank you for watching and see you next time. Bye bye.